So there are different advantages of using MOS sensors. For instance, it was selected as the technology for this project because of their cost effectiveness. They are very cheap, already commercially available on the market. Also, they are very small in size that let them easy to integrate in a larger system, as well as the capacity of providing real-time measurements on site. So for all these reasons, they were selected, MOS sensors were selected as main technology of the project. My role is to improve their performance by looking at which models of MOS sensor are more fitting to particular type of food, along with using thermocycle operation, so finding the most suitable thermocycles to achieve the best performance. So thermocycle operation are a particular type of dynamic operation that can be applied on MOS sensors that let us increase the sensitivity and sensibility of MOS sensor towards quantity and type of gases in the air. To explain how this thermocycle operation improve the performance of MOS sensor, just a quick recap of how MOS sensor works. Basically, a MOS sensor is composed of a particular material with stable electrical properties, but when this material is in contact with the air, according to the composition of the air in terms of type of gases and quantity of these gases, the electrical properties of the material change accordingly to this composition. So basically, the main point of thermocycle operation is to change the starting point of these electrical properties. So it's like starting with a new type of MOS sensor. By doing so, with just one physical sensor, we are able to have a virtual, what we call in the technical field, a virtual sensor array, because on each temperature step to which the sensor operates, the starting condition will change. So it will detect different type of gases and different type of ranges of these gases. There are a lot of types of food that can benefit by the use of MOS sensor. Saying beforehand what are the most suitable for this kind of technology is tough to determine beforehand, because the point is that we need to see empirically what are the reaction of a type of a model of MOS sensor to particular kind of food. So potentially a broad spectra of type of food can be analyzed and studied via the MOS sensor. According to what are the type of models, hardware models and the thermocycles applied on this kind of MOS sensor, we can potentially be able to analyze most of the food types on the market.